Hello, second graders. Today we are working in science on the Unit 4 Environmental Engineering, Lesson 9 Environmental Engineering Portfolio. My name is Mrs. C, and today I'm going to help you complete this portfolio so you can turn it in to your teacher for a grade. Before we begin, let's look at your lesson to see where we should start. I want you to pay attention to something up here. This says Unit 4, Lesson 1. That is because this portfolio begins on Lesson 1, but is not turned in until Lesson 9. That means we're going to have a lot of work to do, and I do not suggest doing it all in one day. I think you should break this project up over at least a few days. Let's look at Lesson 1. Objective. This is what we want to do. In this portfolio, you will think like an engineer about solving a flooding problem. Here are some key words. Dam is a barrier to hold back water. The engineering design process is a series of steps engineers follow to solve a problem. Flood is when water overflows on top of land. Problem is something that is hard to deal with. And a solution is a plan that helps solve a problem. So in this portfolio, we're going to build a couple of dams to help stop flooding, which will solve a problem. You will now solve a problem. You will do what engineers do to solve problems. An engineer is a problem solver. They design solutions. They use the engineering design process. Look at this chart. The engineering design process has 6 steps. Think about each step. So we're going to go through all of these steps today. Ask, brainstorm, design, create, test, and improve. We're going to do all of these steps, and sometimes we might do them more than once. All right, so answer this question. Think about this with your learning coach. What is the second step in the engineering design process? If you don't remember, you can go right back up here and you can check. They plan buildings where people live. They plan roads and bridges. They plan cars that drive on them. An engineer designed the computer you are using. You can solve many problems following the same steps. What to eat for lunch? You have a problem. You are hungry. It is time for lunch. It is the perfect time to use the engineering design process. Ask a question. What am I going to eat? Brainstorm possible solutions. I could make a turkey sandwich. I could make a ham sandwich. I could put cheese on my sandwich. I could add lettuce and tomato. These are all brainstorming ideas. Design a solution. You will make a ham sandwich. You will use toasted whole wheat bread. You will add a slice of Swiss cheese. You will add lettuce and tomato. Sounds delicious. Create your solution. You will get your ingredients together. You will need ham, Swiss cheese, 2 slices of bread, lettuce, and tomato. You will toast the bread. You will slice the tomato. Then you will put everything together to make a sandwich. Test your solution. Take a bite. Is it good? Yes, but it needs something. Maybe some mustard. Improve your solution. Add a little mustard and your problem is solved. The engineering design process is very useful. It is so useful that you probably use it several times a day. You may not even realize it. So here's another question. You have an art project. You need to make a poster. Describe how you would use the engineering design process to do this. So this isn't our portfolio today, but this is something you can talk about with your learning coach, and you can look at these steps to help you. You can think like an engineer about using dams to solve a flooding problem. In this portfolio, you will solve problems caused by flooding. So that's how we are going to use the engineering process. You will do these things. Ask questions about a problem caused by flooding. Brainstorm possible solutions using dams to solve the problem. Design 2 models of a dam. Create 2 models of a dam. Test your models and collect data. Study the data for patterns and think of ways to improve your model. So this is why I think you should spend at least a few days completing this project. You're going to design and create 2 different dams. So that's going to take you a bit of time to gather your supplies and to create your models and to then analyze the data and talk about what information worked and what didn't work. It's going to take you a couple of days at least. Okay, so we're going to use our science journal throughout this entire portfolio, and we're going to turn in those pages to your teacher. So use your science journal to record your work. Your journal should include these things: the questions you want to ask about the problem of flooding, your ideas for dams, your designs for 2 different dams, the results of your tests, and your thoughts about how to improve or make your design better. All right, so in your resource book, you do have a rubric. I'm going to look at this rubric at the very end of our portfolio to make sure that we did everything and that we have everything we need. But you can click here and you can look at it right now if you would like to, just so you kind of know what those expectations are. To save time, I'm only going to look at it at the end with you. All right, are you ready to get started? Let's go. This is the end of lesson 1. So far we haven't really done any work yet. We've just been introduced. So if I were you, I would keep working. I would go ahead and go on to lesson 2 before I stop for the day. Lesson 2 is titled Ask Questions. Remember, that's that first step of our process. Objective. In this portfolio, you will observe, or you will see, how a flood can quickly change the landscape using books and media, like your computer. Here are those keywords: flood, when water overflows onto land, and landscape, a group of things we see outside, like the ground, water, and plants. You are learning to think like an engineer. In this lesson, you will ask questions. You will ask about what happens in a flood. Asking questions is an important first step. You can see right here on our process, ask is the very first step. Why can flooding be a problem? Questions help you understand problems. You might already know a little about a problem. Then you can ask more useful questions to find out more. Watch the comic book video about floods. Floods can change a landscape. Think about why floods can be a problem. So definitely watch this video, and it's going to give you some examples of flooding and how it can cause damage. Next, show what you know and do the activity. So you're going to have an activity that asks you, what are some changes caused by floods? You can select what is caused by floods and what is not caused by floods, and then you can check your answers. Go ahead and do that with your learning coach now. Look at the picture. Talk about the picture with your learning coach. Imagine what this place looked like before the flooding. Ask your learning coach to help you look for more pictures. You can find these in books, you can watch videos on your computer or other media about floods. Then list 3 things that happen when it floods. Write them in your science journal. So here is where we're going to ask questions. Here are some examples that you could try starting with, and I'll show you my example that I have in my science notebook too. Your science notebook might not look like mine. That's okay. As long as you are asking questions, that's the first step of the process, and that will be what your teacher is looking for. So here are my 4 questions. I have 4 because we're going to look at questions 2 times in this lesson. Number 1, what materials can stop water? If I want to stop flooding, I think that's important to know and to ask myself. Number 2, how can I make my dam strong? It needs to stop that water. That water is really strong, so my dam needs to be stronger. Number 3, why is flooding bad for the land? Grass, plants, they usually need water, right? Why is flooding different? And number 4, what kinds of dams work best? So if I can explore and answer this question first, I might have a better idea of the materials I want to use when I build my dam. All right, let's get back to lesson 2. Objective. In this portfolio, you will ask questions to get information about the problem of flooding and how dams are one solution or way to solve that problem. Here are some of these same keywords and a few new ones. We have dam, which is a barrier to hold back water. Design, which means to create a plan or sketch or draw a solution to the problem. The engineering design process, a series of steps engineers follow to solve a problem. Environmental, which means something related to the natural world. And flood, which is when water overflows on top of the land. In this part of the portfolio, you will continue to ask questions about floods. Trust me, if you already have 3 or 4 questions, you don't have to write more, but we will have some more examples to look at. Water is important for life. People and crops need water. So why is too much water a problem? One environmental problem is flooding. A flood happens when the ground cannot soak up water on its surface. The water has no place to go. This can happen when the ground soaks up so much water that it becomes full. Floods can happen when rivers or lakes become too full. If it keeps raining, there is nothing to hold the water. There's another example of a flood in a neighborhood. In the last part of the portfolio, you learned about some effects of floods. You learned that floods can cause problems. You want to find a solution to problems caused by floods. You must start by asking questions. Then you will find answers to these questions. Here are a few questions to begin with. What is a flood? How is a flood dangerous? So if you didn't have your own questions, or if you didn't like the examples I showed you, these could be 2 of your questions, right? Pretty simple ones. Also, think about what other questions can you ask about floods, right? There are lots of questions that we can think of. Look at one question. What are people already doing to solve this problem? That's another question you could ask. Floods do not only affect people, they affect animals too. Engineers look to many places to find ideas that will help them design solutions. One solution for flooding is a dam. How can engineers design a dam? How does a dam stop floods? Those are all really good questions too. New ideas. One idea, 2 designs. A dam is used to hold back water. It keeps water from overflowing. Humans build dams to prevent floods and store water. So here's a human-built dam. Humans make dams with soil, wood, or cement. This one's cement. But beavers build dams too. These dams stop water from flowing so ponds form. They keep beavers' homes from washing away. So beavers build dams made of branches, rocks, and mud. People and beavers both build dams. They build them for the same reason. They build them to protect their homes. Here are some questions you could ask about this solution. How well do dams work to stop floods? How hard is it to build a dam? Are dams good for the environment? Dams are a solution for floods, but are they a good solution? You can find out by asking questions. Here's another activity. You are asking questions about solutions to floods. Which questions will help you decide if a dam is a good solution to flooding? So here are some helpful questions. You can scoot them over here. And here are some less helpful things that you probably don't need to ask. They're not going to give you a lot of information. You can slide them over here and then check your answers. Remember, if you still need questions for your science notebook, make sure you choose some of these helpful ones and not these less helpful ones. Think about the questions you should ask about floods to learn more about why they are a problem. Think about what you should ask about dams to learn more about why they are a solution to floods. So here's ask questions number 2 with some more examples that you can start with if you don't have your questions in your notebook already. So here are 3 questions about floods that are examples. Here are 3 question starters about dams that are examples. So you can write these questions in your science journal. And if you want to stop for day 1, you've got the first step, ask questions completed. We're going to go ahead and move on from lesson 2, and we're going to go to lesson 3. Lesson 3 is titled Brainstorm. That is what we are going to do in our science notebook next. So here's our new objective, or what we want to do now. In this portfolio, you will brainstorm shapes for a dam that would help it hold back water. Keywords: brainstorm, to think of many ways to solve a problem. So they're like ideas. Dam, a barrier to hold back water. Design, which means to create a plan or sketch, a drawing of a solution to a problem. And flood, when water overflows on top of the land. Your goal is to solve the problem of flooding. In this part of your portfolio, you will brainstorm possible shapes for a dam. We finished Ask Questions. Now we're moving on to brainstorm. Look at this image or picture gallery to see different kinds of dams. So go through this gallery and look at all of the different examples. It's going to help you when you start planning your own models that you're going to make of a dam. These dams all solve the same problem. They hold back water. They keep floods from happening, but they look different. They all have different shapes. Some dams are curved, others are straight, others slope downward. Which shape is best? Brainstorm many ideas. A town has a problem. There is a river nearby. The river floods every time it rains. They are worried. They think a flood might damage their homes. They decide to build a dam. Watch the video. So watch this video here about a dam being built and see what happens. Today you will brainstorm ideas for a dam shape. Remember, the goal is to solve a problem. It is to stop a flood. Your dam should be able to stop a flood. You do not want water to flow around, under, or over your dam. Your dam can be built across the river or on the sides. And keep the amount of material you use in mind. If you're building a real dam, more material will cost more. Even this dam, if you need more material that you have to buy at the store, more will be more expensive. Think about these questions with your learning coach. What is the second step of the engineering design process after asking questions? Hint, it's what we're doing right now. Number 2, what does it mean to brainstorm? That's what we're doing. And why should you brainstorm many solutions when you only need one to solve a problem? Why is it good to have more than one idea? Okay, so now we're going to brainstorm at least 3 ideas for our dam designs. You can use modeling clay if you would like to actually build those dams. So you can record drawings or take pictures of your idea in your science journal. Each design should be a different shape. They do not all have to be perfect. You only need one good design to solve a problem. Then you're going to choose your 2 best dam shapes. You're going to choose the 2 that you think would be best at stopping flooding and tell your learning coach why you chose them. Write about your choices in your science journal. So for this, we're going to draw some pictures or make some models, and we're going to write some statements about why we chose those ideas too. So you need 3, but you only need to choose 2. All right, so here are my examples. Here are the 2 that I chose. Idea number 1, idea number 2. I have a straight dam. That's my shape, right? It's straight. And I'm going to make it out of rocks. And then I have a curved dam that I'm going to make out of clay. So my shapes are different and my materials are different. I chose these designs because they remind me of real dams. When I was looking at those pictures, I saw ones that were made out of cement and rocks, and I saw ones that were made out of concrete or sticks and clay, things like that, softer things, mud. So those are my ideas that I'm going to use. Remember, you can come up with more ideas. You can come up with 3, 4, 5, 6, but you're going to choose 2 that you're going to actually build. So draw some pictures, take some pictures. You're going to be turning these into your teacher, so make sure that you have some examples to show. All right, in this portfolio, you will brainstorm the materials to be used in building a dam that would help it hold back water. So I was just talking about those materials that I was going to use in my brainstorming. You're going to need to think about the shape and the materials as well. Keywords: dam, a barrier to hold back water; engineering design process, a series of steps engineers follow to solve a problem; flood, when water overflows on top of the land; and property, a trait that can be measured, observed, or tested. You have been using the engineering design process to solve a problem. You are thinking like an engineer. The problem is flooding. A dam is one solution for problems caused by a flood. First, you ask questions about the problem. Then you brainstorm shapes for the dams you will design. Today, you will keep going with your brainstorm step of the process. You will brainstorm possible materials for your dams. Remember that dams need to be sturdy enough to stop flooding. So you want strong materials. A property is a trait that you can observe. You know that a dam shape is one of its properties. Other properties of a dam are its strength and how long it can last. What materials make a dam strong? View this flip book to learn more. It's going to show you some examples. What materials could you use to make your dam strong? It should be able to hold back lots of water. It should be strong enough not to break or leak. Think about these questions with your caretaker. What materials do people use for dams that are similar to materials beavers use? What materials do people use for dams that have to be built very quickly? What is a metal that people use to make dams? Go back to that flip book if you can't remember and check it out. Complete these activities about brainstorming. Brainstorm a list of materials you could use for your dam design. Write your list in your science journal. All right, so you can just make a list. You can just add 1, 2, 3, 4, and you can list them out, or you can show them in your picture. So that's what I did in my brainstorming section. I showed them in my pictures. I said that this is rocks, and I drew rocks. I said that this is clay, and I drew clay. So if you include them in your brainstorming here, that's fine. If not, if you want to make a 1, 2, 3, 4, 5 list, that's fine. The only reason I didn't do that is because in the design, we're going to do that. We're going to list our materials out. So I didn't want to do it 2 times. All right, so either way is fine. Your science notebook does not need to look like my science notebook. Okay, so here are materials. You're going to write down materials. Here they've got a large container of water, a nail, and here are some steps that they did to test to see if they could test those materials out. Here's an example, someone trying to make something with clay. Based on your test, choose the best material to use for your dam design. Remember, you can use more than one material for a dam. Write your choices in your science journal. So make sure that you have those choices in there. You can use these sentence starters if you would like to write sentences instead of drawing those pictures. All right, now we're going to show how an object and the problem it is designed to solve work together. That's our new objective or what we want to do. Brainstorming, remember, that means to think of many ways or ideas to solve a problem. A dam is what we're making. It's a barrier to hold back water. A flood is what we're trying to stop. It's when water overflows on top of the land. And a property is a trait that can be measured, observed, or tested. So like the strength of your materials, that would be a property. Engineers design a solution. They build a solution. They test the solution they built. If it does not work, they figure out how to fix it. If it does work, they think about how it could be better. Then they improve the solution. But there is something they do before any of these steps. They brainstorm possible solutions based on the questions they have asked. So that's what we're completing in lesson 3. A dam is one solution for floods. Engineers make designs for dams. How do they choose what the dam will look like? So how do they do that? How do you think they choose? They think about those important properties. Dams have properties that make them useful for holding back water. They are large, they are strong, they are made of materials that are hard and can last a long time. They have different shapes, tall, wide, straight, or curved. These shapes let the dam block large amounts of water. All of these properties make dams useful. They help dams solve the problem of flooding. Here's another activity that you can do. Think about this question. How do the properties of dams help them solve the problem of flooding? So you're going to have a statement here. Dams can be very wide, and you're going to add how that solves a problem right next to it. So check your answers when you're done and see how you do on that activity. All right, brainstorm ideas. Use this photo for help. Here's a photo of a really tall, really wide, looks like probably mostly cement dam. All right, if you still need to brainstorm, here are some more sentence starters to help you. If not, we're going to go ahead and move on to lesson 4. We're going to get to that design process. So in your science notebook for brainstorming, you can take pictures if you actually come up with some ideas that you build and that you test. You can draw pictures or you can have some of those sentence starters. All right, now we're going to design. In this portfolio, you will make a model of an object and the problem it will solve. A dam is what we're making models of, right? It's a barrier to hold back water. Design means to create a plan or sketch of a solution to a problem. The engineering design process, a series of steps engineers follow to solve a problem. And a flood is when water overflows on top of the land. In this portfolio, you are following the engineering design process. You are learning to think like an engineer. You have been using the process to solve the problem of flooding. You have learned about how a dam's shape and materials help it solve flooding problems. Now you have reached the design step. In this step, you use your best ideas. You make a plan. So we finished ask, we finished brainstorm, and now we're on to design. The importance of planning. A good plan is important. Think about what can go wrong if you do not plan. Listen to the podcast. So listen to this. It's called The Big Mistake. Make a detailed drawing. It is time to get ready to design your dam. Remember that your dam needs to solve the problem of flooding. You will make a drawing in your science journal. Your drawing will show two dams. Choose only one thing that will be different about your two dams. Your two dams could have the same shape but different materials, or your two dams can have the same materials but different shapes. Your plan needs a drawing of your two dams, a list of the materials used for each dam, and a description of how each dam is built. Do the activity. Which word correctly completes each sentence? So you're going to use those vocabulary words we've been looking at a lot, and you're going to fill them in to complete this sentence or many sentences. Design your two dams in your science journal. Think about how your dams will solve the problem of flooding. Remember, you can choose one of these options. Your dams can have different shapes or different materials. I did both because I want to combine mine at the end, but you can do only different shapes and use the same materials so you don't have to have so many materials, or different materials, but use the same shape so you don't have to make that design differently each time. Excuse me. All right, so work with your learning coach. And try starting with these sentences. I am making two dams with different blank. The materials I will need are blank. The first step in creating my dams will be blank. And then draw your plan for your dams in your science journal. Make sure you write a list of materials you will use. So that's why I chose to put my materials in my design, because I didn't want to do it in my brainstorm and my design twice. And my drawings are in my brainstorm because I didn't want to put my drawings in my brainstorm and my design twice too. I didn't want to double up that work. All right, so here are my materials. For dam 1, I'm going to need a wide pan, many rocks, and water. For dam 2, I'm going to need a wide pan, clay, and water. And here are my steps. So we talked about steps a little bit, but we didn't get into them quite all the way, but I'll go ahead and show you my example. My first step is I will stack and layer many rocks in my first dam. Next, I will build a curved wall with clay in my second dam. And last, my dams will have different shapes and materials. So remember, you can only have different shapes or only different materials. I did both because at the end, my improvement is to combine my two dams. So I did mine a little bit differently. All right, so remember, you can also draw your plan in your science journal, but make sure you have a list of the materials you will use either in your design or your brainstorm step. Make sure they're in there. Now we will tell how the shape of an object helps it solve a problem using a model. Here are those keywords again. Dam, a barrier to hold back water. Engineering design process, a series of steps engineers follow to solve a problem. Flood, when water overflows on top of the land. And model, a model is a representation of a real thing. So it's usually much smaller, it's not as big, it doesn't have always the exact materials you're going to use, but it's just like a practice. You have been using the engineering design process. You are now in the design step of the process. Remember, your goal is to solve a problem. The problem is flooding. Your solution is to create a dam. So we're on the design step right now. Explain a dam's shape. So far, you have designed two dams. You will create models of these two dams. Today, you will explain how the shape or shapes of your dams can help solve the problem. When you explain, you say why something is true. Your explanation should answer this question. Why will this dam shape help solve the problem of flooding? Let's try it. Look at the photo. First, describe its shape. Then explain why the shape helps the dam solve the problem of flooding. This dam, if I look at the bottom and the top, I can see that it's very wide. I think it has a little bit of a curve, but I think it's mostly straight across. It's got a little bit of a curve too. So think that it's really wide and really straight across this top because look how wide and straight this lake is behind it. If we had something that was really curvy or something that was really thin and narrow, it wouldn't block all of this water, right? All right, what should you do to explain why a dam's shape solves a problem? You can choose two correct answers, only two of these are correct, and then check to see if you got those right. Now it's time to work on your own dam design. Look at the model of your two dams in your science journal. Explain how the shape of your dams will help solve the problem of flooding. If you're designing two different shapes, write two explanations. So right here, here are some sentence starters that you can add into the design section of your science journal. This is a really good stopping point for another day. We've done brainstorming, we've done designing. I'm going to go ahead and go into lesson 5, but this is a good part to stop at before you create your models, before you actually build your dams. All right, so this is lesson 5. Our new objective is, in this portfolio, you will make two models of a dam, changing the shape of the dam or the materials used. Here are our keywords. A dam is a barrier to hold back water. The engineering design process is a series of steps engineers follow to solve a problem. And a model is a representation of a real thing. It's like your practice model. You have been learning to think like an engineer, and you are following the engineering design process. Now you are ready for the create step of the process. In this step, you follow your plan. You will create models of your two dams. Why two? When you make two, you can compare them. You can see which one is better. You will make one dam different than the other. You will make it a different shape, or you can use different materials. Then you will check to see how well your dam works. You will test it using weights. You will test one, then you will test the other. So look at this. Ask, done. Brainstorm, done. Design, done. Now we're on the create step. Using models. Before engineers build a full-size dam, they create a model. They can test their model designs and they can improve the designs. But what is a model? A model is a representation of a real thing. It can be a drawing, it can be an object. A model helps people understand something they can't easily see. You can make a model of Earth. Your model would be smaller than the real thing. You could make a model of a tiny bug. Your model would be larger than the real thing. So here is a model of our solar system, and here is a model of an eye. Isn't that interesting? Here are some steps for creating your model dams. Gather the materials on your list. Follow your plan. For one of your dams, use different materials or change the shape. Make sure your two dams are different from each other. If problems come up, do your best to solve them. Pause to ask yourself questions to decide if your model is the best choice, and take notes or photos as you go. Here's another practice activity. It says, what do you know about models? You're going to drag these words and you're going to fit them into each sentence, and then you can check your answers to see if you got them right. All right, so create your model dams. Remember, you're creating two models. Follow these steps. These are the same steps, so I'm not going to read them again. Down here are some sentence starters that you can add to the model section of your notebook. So here is my example. I wrote, my two models were built differently. The rocks were hard to squeeze close, but the clay was easier. So these are some things that I discovered when I was building my models. All right, that's the end of lesson 5. Let's go on to lesson 6, where we're going to test our models. Objective. In this portfolio section, you will collect data by testing two models with weights. A dam is a barrier to hold back water. Data are pieces of information, and a model is a representation of a real thing. So before we move on, before we test, let me show you my examples of my models. So here's a rock dam. You can see I have some sticks and things in there too. The rocks, they stick together, but they don't get so close, right? There's gaps and holes, so it looks like some water might be able to escape through. And then here is the clay. You can see it's curved around, and you can see it's all one solid piece. I was able to mold and shape it a lot better. I was able to make that curve, and I was able to keep all of the materials closer together. So that was really helpful. All right, so let's test our models. You are ready to move on to the next step, which is test. In this step, you will test your models. To test your models, you will add weights to them. You will collect data on how strong they are. Look, we're almost done. Test, and then one more step before we finish. The force of water. A dam needs to be strong. Water applies a lot of force to a dam. If the dam is too weak, it will break. Watch this video. And then do this activity. Which statements about dams and testing models are true? You're going to select true if you think the sentence is correct and false if you think the sentence is wrong. Test your model dams. You can test your model dams. You will need to follow these steps. Number 1, set your dams on a level surface. Number 2, add one weight at a time to the first dam. Number 3, record how many weights the dam can hold using tally marks. Write the tally marks in your science journal. And then test the second dam in the exact same way. Books make for good weights, but anything you can stack will work. My dams were not big enough to stack books on, and your models of dams might not be either. What I used toy cars. They were small, and even though they were a little strangely shaped, I was able to stack them on top of each other pretty easily, so that's what I used. You can use anything that you can stack. All right, so write about testing your models and try starting with these sentence starters. I tested my models with, I used tally marks to, I tested to see which dam was ... All right, so here is my example. I like to draw pictures, so I drew some pictures of my test. I tested my models with toy cars, so you need to tell your teacher what you're using for your weight. So if you're using books, that's fine. If you're using something smaller, that's fine too, but make sure you have it in your journal. Here's a picture of my rock dam. I was only able to stack 3 toy cars on, and my rocks actually started shifting and moving away when I did that. For my clay dam, I was able to stack 5 toy cars, and I think I could have stacked more. I think it would have supported the weight, but my cars were getting really wobbly. So my dam did not shift or move when I stacked those cars on top. Here are my dam test results. I made a pictograph. So down here there's a key and it says toy car equals 1 car. For dam 1, 1, 2, 3 cars is what I was able to stack. And for dam 2, 1, 2, 3, 4, 5 cars is what I was able to stack. I also have a bar graph down here. We're going to look at that in your lesson in just a moment. And I've got my description on the side. It says number of cars. That's what these numbers mean. And then for dam 1, it goes right up to 4, or right up to 3, I'm sorry. And then for dam 2, it goes right up to, is that 5? Yeah, right up to 5. So I filled in the square. So I've got 1, 2, 3 squares here, 1, 2, 3, 4, 5 squares there. All right, and we're going to look at that in your lesson in just a moment. So this is the end of lesson 6. Let's go ahead and move on to lesson 7. If you're taking a break again, that is absolutely fine. You can continue lesson 7 the following day. Remember, we're not going to turn this in until lesson 9, so we have a little bit more to go. All right, in this portfolio, you will graph data from tests of 2 objects. So that's why I just showed you, because that was in my test section. So that is what you're going to do now too. A bar graph is a way to organize data that uses bars to stand for numbers of things. Data means pieces of information. And a pictograph is a way to organize data using pictures to stand for numbers of things. In the last part of the lesson, you began the test step of the process. In the test step, engineers test their designs to see if they work. So we're still there right now. We're still on the test step as well. A pictograph is a way to sort data. It uses pictures. Each picture stands for a number of things. Select the button, then select each pin to learn more about the parts of a pictograph. There are 4 pins. So click on these different pins and look at this pictograph and it will tell you more about it. You can see the key down here too, which is very important. Use a bar graph. Another graph you can create to sort data with is a bar graph. It can help you see the results of your test. Danny tested her 2 model dams. She piled books on her dams. She tallied how many each could hold, and then she sorted her data using a bar graph. So she has the number of books. She was using books to stack. And then she has dam 1 and dam 2. Dam 1 goes all the way up to 6. Dam 2 goes all the way up to 4. Danny tested her two model dams. She piled books on her dams. She tallied how many each could hold, and she sorted her data in a pictograph. So the information in this pictograph is the same as the information in that bar graph. It's just shown a different way. So her key says this little square or rectangle equals one book. So she has 6 rectangles here for dam 1, and she has 4 rectangles here for dam 2. All right, so answer these questions about the pictograph and then check your answers to see if you are correct. Here is a different bar graph. Rajesh sorted his data using a bar graph. Look at the graph, then answer the question. So his dam 1 held 4 books and his second dam held 7 books. Which model dam would be better for holding back water and why? So look at the information here, talk about with your learning coach, and think about which one is probably going to hold that water back the best. Now it's time to sort your data from your test in a pictograph. So you're going to draw either a pictograph or a bar graph. You don't have to do both like I did. And then you're going to describe it in a few sentences. So right here, you can talk about in your pictograph, what did you use pictures of? Or if you did a bar graph, you can talk about what your tallest bar was and what that means. And then think about that data. So in mine, I have this sentence. My dam number 2 held more weight compared to dam number 1. I can see that information in both my pictograph, where I have 5 cars, and in my bar graph, where my bar goes up all the way through number 5. So looking at those graphs can help you understand and write your data about how your dams did. All right, so let's go back to your lesson. Now you will find patterns in data which show which model worked better. So you're going to analyze your graphs just like I just did. Remember, a bar graph is a way to organize data that uses bars to stand for numbers of things, and a pictograph is a way to organize data using pictures to stand for numbers of things. You can use either one of those. You are working on the test step of the process. You already tested your dams. You made a pictograph or bar graph of your data, and now you will use your graph to find a pattern in the data. How do scientists and engineers use data? They look for patterns. Look at this chart. Do you see a pattern? 65 degrees, 69 degrees, 70 degrees, 74 degrees, 76 degrees. What's happening? The pattern is that the temperature goes up over the week. So each day the temperature is getting higher. Ari does 2 tests to see how strong his dam is. Then he graphs the data. For the first test, he creates a pictograph. It shows how many 20-pound weights his 2 model bridges can hold. It shows which model bridge held more weight, and it shows which held less. So each one of these circles equals 20 pounds. So 20, 40, 60, 80, 100. His first bridge held 100 pounds, but look, 100, 120, 140, 160. His second bridge held even more. For the second test, he sorts his data using a bar graph. In this test, he uses 30-pound weights. So for this one, it's counting by 30s, 30, 60, 90, 120, 150. So bridge 2 was still stronger. Compare the 2 graphs. What pattern is shown? What can scientists and engineers find by looking at data? Talk about that with your learning coach. And then think about how can you learn from your dam data? And what will you look at to find a pattern in your dam data? And how can data be shown in different ways? Talk about those questions. All right, now it's time to look for patterns in your own data. Use your pictograph or your bar graph. Which dam held more weight? Tell your learning coach, then write the information in your science journal. So you just need a short sentence just like I showed you. You could say my pictograph shows or my bar graph shows, or you can write dam 1 held, and you might write more or less right here, weight compared to dam 2. So write what your data shows in your science journal. All right, we're almost done. We're going to go to lesson 8 now, find patterns, and we're going to work on that improve step. In this portfolio, you will describe how well the models worked using data. A dam is a barrier to hold back water. Strength means something that works well in a design. Weakness is something that does not work well in a design. Now you will decide on changes to improve your design based on the data you collected. This means you will make it better. Engineers often improve their designs many times. They want to get the best design. Today, you will decide how to improve your design. So look, we're right here on the last step. You will describe the strengths and weaknesses of your dams. Then you will decide how to improve your design. View this flip book to learn more about strengths and weaknesses. So go ahead and watch that with your learning coach. And then do this activity. What are strengths and which are weaknesses of a dam? So if it's a strength, something that's good, you're going to move it over here. A weakness, something that didn't work well, you're going to move it over here, and then check your answers. Here are some steps you can follow to improve your dams. You can identify the strengths first and ask what worked well. Next, you can identify the weaknesses and ask what did not work well. And then you can think of changes that will fix the weaknesses and write in your science journal. So work with your learning coach, and here are some sentence starters that you can start with. I'm going to show you my example in my science journal. Yours doesn't have to be the same, and it's probably not going to be the same. That's okay. Here are my sentences. I can improve my dam by using both materials. I realized that my rocks were really strong, but my clay was really stiff and it didn't move. So I thought putting those together might be best. My best design was combining dam number 1 and dam number 2. So when I put those materials together, it did hold the most. The rocks made my clay stronger and the clay didn't move. So I just wrote a lot of notes about how I could improve it and then what happened and why it was an improvement, why it was better. All right, so let's go back to your lesson and let's look at some more examples. Now you will describe which model worked better using that data. A dam is a barrier to hold back water. You built and tested your dams. You thought of some ways to improve your designs. Today, you will decide which design is better and explain why. How can you decide which of your dam designs is better? You might get some ideas from this podcast. Listen to what Josie, Malik, and Alan thought of their dam designs. So this is called Builders Gonna Build. Go ahead and listen to this, and they're going to discuss their dam designs and what was best. Use data. You can use data to support an idea. Here is how one student used data to support an idea about their dam designs. My curved dam is better than my straight dam. Both dams were strong, but the straight dam tipped over. The curved one stayed up. So just like I had some sentences about that in my science journal, you're going to write some sentences in yours. This is another example of what someone learned about their dams. So everyone's information might be different. Engineers want a design that works. That is the most important thing. But they think about other things too. Sometimes two designs will both solve the problem, but one might be stronger. One might be cheaper. One might be easier to build. One might last longer. One might even look nicer. Engineers have to think about all of these things. Look at the photo. This is the Hoover Dam. It took 5 years to build and it cost $49 million. Thousands of workers helped build it. Good thing we don't have to build something like that, right? Just models for us. Think about these questions with your caretaker. What problem can dams solve? What do engineers need to do before they build their final dam? And what do engineers think about as they decide on the best design? All right, so think about your dam designs and describe your best design. Say why you think it is best and write it in your science journal. So here are some of those sentence starters. My best design is blank. It will solve the problem of blank. And remember, if you don't want to write sentences like I did, it says you can draw pictures too. So you could draw pictures of your new and improved design and add that into your improved section. That would be fine as well. We are done with lesson 8. That means we are moving on to lesson 9. We are going to do a reflection. So you do have one more section in your science journal to complete before we turn it in. In this portfolio, you use the engineering design process to solve a problem. You wanted to solve problems caused by flooding. Ask, brainstorm, design, create, test, improve. You did it all. Think about your portfolio project. look at what you wrote in your science journal. So go back to all those pages and do like a little review of all of the information that you've done. Then think and talk about your portfolio project with your learning coach. You can use these sentence starters for help. So in your reflect section, you're going to write your answers in your science journal, and you might want to write some new questions you have if you have any new questions as well. So here's my example for my reflection. I learned that rocks need to be connected for a dam to work. My rocks slid away, they let water through. It was hard to stack the cars on top of the dams, right? It was hard to stack anything on top of them, I think, for some of us. So those are some reflections, some things that I observed, that I noticed, or that I learned during this portfolio project. So your reflections, they won't be the same as mine. That's absolutely okay. All right, so add your reflection to your science journal. And then we're going to look at our rubric really quick, and we're going to make sure that we have everything to submit. It is a lot. Get ready to turn in your portfolio. Make sure you have each part. Work with your learning coach. So for the questions, I have my questions combined. I don't have two sections, but I do have an ask questions section that has at least two questions. So you don't have to have 2 pages. 1 page is fine as long as you have more than one question. So questions are going to come first, then your brainstorming, your materials, right? I put mine actually in my design. They can come after your brainstorm. They can come after your design. They need to be in one of these 2 sections. Make sure they're somewhere right here. So I had brainstorming, design, and I started with materials, and then my steps. So my steps of my design came next. Models, make sure you have pictures of those models or drawings of those models. Your tests, so that's when you're stacking those things on them to see which one is stronger, right? So you're testing both models. Then maybe you're making those improvements. You need those improve sentences, those observations you made or pictures. And then you tested it again, right? You might even test it again to see if it's stronger. What could you change? Then make sure you have that reflection to turn in as well. So it's a lot to turn in, but don't think that every single one of these has to be a different sheet. Some of these can be combined into one section, and that's okay. Just make sure that you go through each step. All right, let's look at your rubric really quick. So in the Ask Questions section, remember, you're asking questions about this problem. Your questions need to be related to flooding or dams. You want to ask questions that make you think about the problem and questions that have a good reason. So you don't just want to make up silly questions for no reason. Brainstorm, make sure you're imagining different solutions, things that might fix or solve the problem. Make sure that you ask questions about what you need to do in your design, and make sure that you choose the ideas or that you think will be best. All right, in the design section, you need a detailed plan. So that means you need those materials, you need those pictures, you need those sentences. Make sure that your plan is clear and fully finished in the design section. For create, follow those plans of your own design. Create a physical model. So remember, you're creating something using real materials, rocks, clay, sticks, mud, any materials that you got ideas from your lesson. All right, and then use your plan and those materials to actually create and build your model. When you test it, make sure you use a new tool that can improve an old tool to solve a simple problem. So remember, when you're testing it, make sure that you're thinking about how to fix any problems. Make sure you record any problems, and make sure you collect that data, that information about how many things you stacked on top of your dam. For the improvement section, remember, you need to make meaningful improvements based on what you learned, and you need to use your data to help you make those improvements too. So you don't just want to change things for no reason. You want to say, hey, I can tell this one was stronger, I can tell this one was weaker, this is what I need to do. So if you do all of that, your total hopefully should be 30 out of 30 points, or at least very close to it. All right, so you're going to turn all of this in to your teacher on the next page. I'm just going to go through my notebook super quick because I know this video is very long because this portfolio is very long. Here's my Ask Questions section, my Brainstorm section, my Design section, my Models section. Remember, I had some pictures of those models as well. My Test section with my graphs. Remember, you need a pictograph or a bar graph. My Improve section, and my reflect section. So this is what you need. Your notebook doesn't need to look like mine, but you need to make sure you turn in something from each of those steps. That way you can get the best grade. All right, guys, if you have any questions, reach out. I hope this video was helpful, and I hope you have a wonderful day. Goodbye, goodbye.